Hello and welcome back to another episode of Brandon Does Cyber. Today we are going to be continuing on from our Windows exploitation basics. In the last episode we knocked out our Windows fundamentals and we learned a little bit about Active Directory, understanding about what domain controllers are, how Active Directory works, and overall just kind of learning more about the Windows operating system. So today we're going to get into the Metasploit and introductions to how it is to how to use it, what it is, kind of some different modules that maybe we would use for the framework. And so, hope you enjoy this episode as we get into it. So, I've already started the machine up, so let's go ahead and read. Metasploit is the most widely used exploitation framework. It is a powerful tool that can support all phases of a penetration testing engagement. So, from information gathering to post exploitation, Metasploit has two main versions. So you have Metasploit Pro, excuse me, Metasploit Pro. This is the commercial version that facilitates the automation and management of tasks. This version has a graphical user interface, and then the OG Metasploit framework, the open source version that works from the command line. This room will focus on this version, installed in the attack box, and most commonly used for penetration testing Linux distributions. So Kali, Parrot OS, etc. Metasploit framework is a set of tools that allows information gathering, scanning, exploitation, and exploit development, post exploitation, and more. While the primary usage of the Metasploit framework focuses on the penetration testing domain, it's also useful for vulnerable research and exploit development. So there's main components of the Metasploit framework. So it's MSF console, the main command line interface, modules, so supporting modules such as your exploit scanners payloads, tools, so standalone tools that will help vulnerability research, vulnerability assessment, or penetration testing. Some of these are MSF Venom, Pattern Create, and Pattern Offset. Or we'll cover MSF Venom within this module, but Pattern Create and Pattern Offset are tools useful in exploit development, which is beyond the scope of this module. This room will cover the main components of Metasploit while providing you with a solid foundation on how to find relevant exploits, set parameters, and exploit vulnerable services on the target system. Once you complete this room, you'll be able to navigate and use the Metasploit command line comfortably. So, we're going to start this machine. We've already done it, and we're going to move on. So, main components of Metasploit. While you're using this, your primary interaction is going to be within the Metasploit console. So you can launch it using MSF console. So here, this is how that looks. What I do like about MSF console is that you can get a pretty little picture whenever you do run it. You can definitely silence it with the TAC queue, but here we got a bunny. Looks like it's a Matrix little reference. Wake up Neo, the Matrix has you. Follow the white rabbit. So this is what Metasploit looks like, right? This is a very basic overview of it. So um, this will be your main interface, interact with different modules of the framework. So modules are these small components within the framework that are built to perform a specific task, such as exploiting a vulnerability, scanning a target, or performing a brute force attack. So before we dive into the module, there's going to be a few current concepts to clarify. These are vulnerability, exploit, and payload. Exploit is a piece of code that uses a vulnerability present on the target system. A vulnerability is a design coding or logic flaw affecting the target system. Exploiting a vulnerability can result in disclosing confidential information or allowing the attacker to execute code on the target system. And then there's payload. Payload is an exploit that will take advantage of a vulnerability. However, if we want the exploit to have the result we want, so say gaining access to target system, read confidential information, etc., we need to use a payload. Payloads are the code that will run the target system. So, modules and categories under each one are listed below. They're given for purposes, but you want to interact with them through the Metasploit console. So, auxiliary. Any supporting modules such as scanner, crawlers, and fuzzers can be found here. So, I want to just take this quick little snippet here. So if you run tree, tac L, want auxiliary, you can see here that this is all the different type of auxiliary modules that they may have. We have encoders, so we'll copy and throw that into our notes as well. This is what's going to allow you to encode the exploit and payload in the hope that things like signature-based antivirus solutions can miss that. And so signature-based antivirus and security solutions have a database of known threats. They detect these threats by comparing files to this database and raise an alert if there is a match to some suspicious activity. Thus, encoders can have a low success rate as antivirus solutions can perform additional checks. We have invasion. So while encoders will encode the payload, they should not be considered a direct attempt to evade antivirus software. On the other hand, invasion modules will try that with more or less success. And then there's exploits. So exploits neatly organized by target system. They're just how we're going to actually take advantage of that vulnerability. Then we have knobs. Knobs, or no operation, do nothing. Literally, they're represented in the Intel x86 CPU family with OX90, following which the CPU will do nothing for 1 cycle. They're often used as a buffer to achieve consistent payload sizes. And then payloads. So payloads are codes that will run against the target system. Exploits will leverage a vulnerability in the target system, but to achieve that desired result, we will need a payload. So examples could be getting a shell, loading a malware or backdoor to the target system, running a command, or launching calc.exe as a proof of concept to add to your penetration test report. So starting the calculator on the target system remotely by launching the calc.exe application is a benign way to show that we can run commands on the target system. Running command on a target system is already an important step, but having interactive connection that allows you to type commands that will be executed on a target system is better. So such an interactive command line is called a shell. Metasploit offers the ability to send different payloads that can open shells on a target system. So you're going to see 4 different directories are in payloads. So you have adapters, singles, stagers, and stages. So we'll take this as well. We'll copy that too, because that's talking about reverse TCP. So, adapters. Adapter wraps a single payload to convert them to a different format. So, a normal single payload can be wrapped inside a PowerShell adapter, which will make a single PowerShell command that will execute the payload. Singles, a self-contained payload. This adds user, launch, notepad, etc. that do not need to download an additional component to run. Stagers, responsible for setting up a connection channel between Metasploit and the target system. So this is useful when you're working with those stage payloads. So a stage payload will first upload a stager on the target system, then download the rest of the payload, the stage. This provides some advantages as the initial size of the payload will be relatively small compared to the full payload sent at once. And then stages. They're downloaded by the stager. This allows you to use larger size payloads. So Metasploit has a subtle way to help you identify single, also called inline payloads and stage payloads. So there's generic, as you see here, or there's just like Windows x64 shell reverse TCP. Both of these are reverse shells. The former is an inline or single payload, as indicated by the underscore between shell and reverse, while the later is a stage payload, as indicated by the slash between shell and reverse. So, as you see, the inline is going to go, it's going to say, hey, I want to just try doing this. I'm not going to download anything. I'm just going to try to create some type of shell. And then the stage one here with the Windows x64, because it needs more information, you're actually doing stuff with it. It's going to say, hey, we're going to kind of create that test little stage, and then once that works, cool, we're going to send the rest of it to finally get that connection established. And then there are post modules. So if you wish to familiarize yourself with these modules, you can find them under the modules folder of your Metasploit installation. For the tech box, they are under Op Metasploit Framework, Embedded Framework modules. Alright, so what is the name of the code taking advantage of a flaw on the target system? That's an exploit. What is the name of the code runs on the target system to achieve the attacker's goal? That's a payload. What are self-contained payloads called? I believe those are just payloads. Or is this saying like self-contained payload? Oh, singles. That's right. Okay. Yeah, singles. Okay. Amongst singles or staged. Well, it's not a single though, because it said it was staged earlier. I thought. Yeah, the former is an inline or single payload, while ours is staged payload. Yeah. Is it because of the underscore? Oh, I thought it was. I thought it was this reverse shell. Okay. Yeah, that makes sense because it's doing the underscoring. Okay. All right. MFF's console. So, as previously mentioned, the console will be your main interface to the Metasploit framework. You can launch it by using MSF console command on your TechBot terminal or any system the Metasploit framework is installed on. So here, then you ran MSF, give them a little funny prompt. So once launched, you'll see the command line changes to MSF6 or MSF5, depending on the installed version of Metasploit. I believe ours is 6. Yeah. So Metasploit console can be used just like a regular command line shell. As you can see below, the first command ls, which lists the contents of the folder from which Metasploit was launched using the MSF console command. So here they did ls. So I can do it here too. So ls, and you see this is from my desktop. Oh, present working directory. Let's see. F is followed by ping sent to Google DNS IP 8888. As we operate from the tech box, which is Linux, we have to add the tag C option. So only a single ping was sent. Otherwise, the ping process will continue to stop using Control C. So here they did a ping, same thing, basically showing that it has the same functionality as if you are, looking at your normal Linux system. It's just in a different like command line prompt. So it's going to support most Linux commands, but will not allow you to use some features of regular command line. So it does not support output redirections. So here you can't take help and send it the outputs to help.txt. So it doesn't do that. So while on the subject, the help command can be used on its own or for a specific command. So below is the help menu for the set command we will cover soon. So here they ran help set and gives information. You can use the history command to see commands you typed earlier. And so here, again, different things you ran. An important feature of MSF console is the support of tab completion. This will come in handy later when using Metasploit commands or dealing with modules. So if you start typing HE, press tab key, you'll see it auto completes the help. So we can try that right now. So HE, I press tab, completes the help. It's also managed by context. So this means that unless set as a global variable, all parameters settings will be lost if you change the module you decide to use. So we have used the MS17010 Eternal Blue exploit. We set the parameters such as our host. If we were to switch to another module, so a port scanner for example, we need to set the R host value again, as all those changes will be what we have made remain in the context of the Eternal Blue exploit. So looking at example below to have a better understanding of this feature, we'll use this exploit for its illustration. So you type in the use exploit Eternal Blue command. See the command line prompt change from MSF6 to MF6 exploit Eternal Blue. So we'll do that real quick just to show. So here we don't have anything. We want to use this exploit. And so here our command line changes. And so let's see. Yep. Eternal Blue is exploit allegedly developed by the U.S. National Security Agency (NSA) for vulnerability affecting the SMB version 1 server on numerous Windows systems. SMB, server message block, is widely used on Windows networks for file sharing and even for sending files to printers. Eternal Blue was linked by the cybercriminal group Shadow Brokers in April 2017. May 2017, this vulnerability was exploited worldwide in the WannaCry ransomware attack. So they used it and they gave them that. The module to be used can all be selected with the use command followed by the number at the beginning of the search result line. So while the prompt has changed, you'll notice we can still run as previously mentioned. This means we did not enter a folder as you typically expect in operating system command line. So here they still ran ls, still got the same information. Their present working directory did not change. It's just that their command line here did change for the exploit. So the prompt tells us now a context set in which we work. You can see this protecting the show options command. So we can do show options here. And so now we can see this is all the different options we have for the module. Oh. And so we can set our host, our port, domain password, all that fun stuff. And then we have our payload options here. So see over here it says no payload configured defaulting to it. So every single exploit or payload needs a actual payload with it, like an exploit needs a payload with it. So we're not only exploiting it, we need that payload to actually do what we want on the system, right? So here it came back to the reverse TCP, so it just allows us to have a shell when we exploit that vulnerability. So this will print out options related to the exploit we had chosen earlier. Shown options was to have different outputs depending on the context the exploit is used in. The example above shows that this exploit will require we set variables like our host and our port. On the other hand, a post-exploitation module may only need to set a session ID. So here it says required, we have to set these two. This one you can set it, but it's usually just something kind of vague or random, right? Some of these it depends on the exploit, but these are kind of preset already, so you don't normally have to change those. But here with the session ID, so for this one they have a post module, so this is what you're going to be using after you exploit a vulnerability. You have that interpreter shell on the system, so you can use post modules where you can say I want to set the session ID to say 1, right, for the first interpreter session I have, and I can run this onto it to enumerate domain users. So the show command can be used in any context followed by a module type, so auxiliary, payload, exploit, etc., to list all of the available modules. So example below, those payloads can be used with the MS-17 internal blue exploit. So we can do here show payloads, and there's 73 of these. If used from the MSF console prompt, the show command will list all modules. So the use and show options command we've seen so far are identical for all modules in Metasploit. You can leave the context using the back command. So if we want, we can press back and it'll go back. Further information on any module can be obtained by typing the info command with this context. So here we have internal blue, so we can do info. And we got information about internal blue. We see, who is it created by, the name of it, all the information, the targets that is actually going to exploit, some payload information, so like description, how the payload works or exploit works, so some different references for CVEs, so a lot of good juicy information. You can also use info command followed by the module's path, so here you could do info and this path. Info is not a help menu, it will display detailed information on the module such as author, relevant sources, etc. So one of the most useful commands in MSF console is going to be search. This command will search the entire database for modules relevant to the given search parameter. So you conduct searches using CV numbers, exploit names, internal blue, heartbleed, etc. on a target system. So here they did search MS17010, and you got some auxiliary stuff, so a scanner to see if it is detectable for that vulnerability, the exploit, so actually using internal blue, some pass a hash, maybe stuff here with the ps exec, some remote code execution, so a lot of good information. So the output of the search command provides an overview of each return module. You may notice the name column gives us more information than just the module name. So you can see the type of module, so here, auxiliary exploit, category of the module, so is it admin, a scanner, Windows, etc. You can use the module's return and search result with the command use followed by the number at the beginning of the result line. So we ran search here, and you can do use 0 to get this, or maybe info 0 to get information about this command before you choose it. Another piece of information returns a rank column. So this section here, exploits are rated based on the reliability, and this provides their respective descriptions. So here we can copy this. We'll throw that in here into our notes. So here you can see there's excellent, great, good, normal, average, low, manual. So a lot of different levels there. You can direct the search function using keywords such as type and platform. So you can say type as in like an auxiliary module, or maybe a payload or exploit, whatever it may be. And then you can say, they said telnet. So auxiliary module for telnet, and it gives you all of those for it. So remember that exploits take advantage of vulnerability on the target service or system and may also show unexpected behavior. A low-ranking exploit may work perfectly, and an excellent ranked exploit may not. Or worse, crash the system. So, how would you search for a module related to Apache? So, just search Apache. Who provided the auxiliary scanner SSH login module? Look at the hint. Use the info command. So, we're going to copy this. Info. So, Todd B. So, working with modules. You can launch the target machine attached to this room to replicate the example shown below. Any Metasploit version 5 or 6 will have menus and screens similar to those shown here, so you can use the TAC box or any operating system installed on your local computer. Once you've entered the context and menu, using the use command followed by the module name, as seen earlier, you'll need to set those parameters. Most common parameters you'll use are listed below. Remember, based on the module used, additional or different parameters may have to be set. So it's good practice to use show options command to list the required parameters. All parameters are set using the same command syntax. Set, parameter name, and the value. So before we proceed, remember always check the prompt to ensure you are in the right context. When dealing with Metasploit, you may see 5 different prompts. The regular command prompt, you cannot use Metasploit commands here. So this regular command prompt. And the MSF console prompt. So as you see, there's no context set. So you can't really run those specific commands to set the parameters and run modules. You have the context prompt here. So you can use and set those commands, choose whatever you want to have there for the requirements at once. And you can use context-specific commands. So here they're setting our host. And then the interpreter prompt. Interpreter prompt is an important payload we see later in the module, but this means that it is actually executed and you have the session onto the target. And so you can run commands, maybe not Metasploit commands, but system commands, like whatever you're dealing with to that system. And there are some interpreter specific commands also that you can run as well. And then a shell on the target system. So this is you actually on that system running regular command line, whatever commands that can actually be ran on that system. So again, show options, all the different options for the commands. So some of these parameters require value for the exploit to work. Some require parameters will be pre-populated. Make sure you check if these should be made the same for a target. So web exploit could have an ARP port, so their port on the target system. Metasploit will try to connect to, run the exploit. Value preset at 80, but your target web application could be using port 8080. So in this case, say instead of port 445, it's actually 9999. Well, this is the default port that it would use. So you can go in there and reset it to 9999 for the R port. So in this example, we set the R host parameter to the IP of our target system using the set command. So they're setting it. They do show options, making sure they have the host, the R port. They have their interpreter reverse TCP for their payload, and then their exploit target. Once you set a parameter, you can use the show options command just to make sure it's set correctly. So these are the parameters are most often used. So R host, so the remote host, the IP of the target system. It's a single IP or network range that can be set. This will support the CIDR notation or network range. You can also use a file where targets are listed. So one target per line using file path of the target file.txt, as you can see below. So here, this is the targets.txt. So they have a single line for every single target. They set our host to the file, especially file here, and then show options. You can see the our host is this file. So I'm going to copy these, and I'm going to copy this image too, because it could be useful for, especially if you're working with creating multiple targets, having that line there. So our port, remote port of the target we're trying to attack, right? The payload, this is what you're wanting to use alongside the exploit. L host, the local host, so your machine. The L port, the port that you want to connect back to. So this can be anything, just as long as it's different or not being used by another application. In this session, so this is going to be the session ID that maybe you're going to be running those post exploitation modules on, those post modules, when you're actually on the system. You can override any set parameter using set command again with a different value. You can also clear any parameter values using the unset command, or clear all set parameters with the unset all command. It's also a good piece there. So here they unset all, they flushed the database, and now all those preset things that they'd already worked on, or the things that they actually made, were unset. You can use the setg command to set values that would be used for all modules. So setg command is used like the set command. The difference is that if you use a set command to set a value using a module, and you switch to another module, you need to set the value again. Setg allows you to set the value so it can be used by default across different modules. You can clear any value set with setg using unsetg. So I'm going to going a little zoom in there, didn't mean to do that. We're gonna copy this and throw that in. So here they have an example below. So they're using the exploit to set the R host value to the setg instead of the set command. So we use a back command to leave the exploit content. We use an auxiliary, this module scanner, to discover MS17 vulnerabilities, and show options. It shows our popular IP of the target system. So they use this exploit. They set GR host to be this IP. They backed out, they use a different module, and they show the options, and now that is preset for the new module. Sets a global value that we use until you exit Metasploit or clear it using SSG. So using modules, once all module parameters are set, you can launch a module using the exploit command. Metasploit also supports the run command, which is an alias created for the exploit command. So word exploit did not make sense when using modules that were not exploits, so port scanners, vulnerability scanners, etc. So exploit command can be used without any parameters or using the TAC-Z parameter. The TAC-Z parameter will run the exploit and background the session as soon as it opens. So it's a good piece there too. So here they did exploit TAC-Z. This is starting up in the background, doing all this stuff. And once it gets done, you can see that there was this Meterpreter session 2 open. And so what will happen is once that session opens up, it will change this line into Meterpreter, and you'll be into that. So maybe you want to run this in the background, maybe not actually have the Meterpreter just pop up onto your screen. Maybe you want to look at other stuff while this is doing this thing. And so by doing the TAC-Z, it's in the background, and you can pull it back up using sessions. And we're about to get into that too. So this returns you from the context prompt from which you run the exploit. Some modules support the check option, so check if the target system is vulnerable without exploiting it. So sessions, actually I'm going to copy that too, that's a good point. So sessions, once a vulnerability has been successfully exploited, a session will be created. So this is a communication channel between the target system and Metasploit. So you can use background, the background is the command session, go back to your MSF console prompt. Alternatively, Control Z can be used for background sessions. The sessions command can be used from MSF console prompt to see your existing sessions. So here, I have 1, 2 sessions. Then can back out of this sessions again, and you can see all the different sessions. To interact with a session, you can use the sessions tag I command followed by the desired session number. So session tag I2, and now they're part of this session. All right. So how would you set the L port value? So set L port So setting the global value, so set G, right, our host to 10, 10, 19, 23. And then what command would you use to clear a set payload? Clear a set payload. Was it like unset G? I remember seeing that. Unset all. Okay, let's see. What command do you use to proceed with exploitation phase? You can do exploit or run. And so that's it. So, as we've seen so far, Metasploit is a powerful tool that facilitates the exploitation process. The exploitation process comprises three main steps: find the exploit, customize the exploit, and exploit the service. So, Metasploit provides many modules that you can use for each step of the exploitation process. Through this room, we've seen the basic components and their respective use. It would be best to use if you also, if you use the MS-17 to gain access to the target VM. We will cover Metasploit and its components in more detail. Once completed, this module will give you a good understanding of the capabilities of Metasploit. So, just to, so we see here, so we do show options. So we can go and set this real quick, right? So, just to try it out and see what it looks like. So, set it, set our R port, or actually, nope, set our L host. And if this is a neat little trick, so you can do a tab complete for L host to get your IP. You can also do, I think, like if you have different interfaces and maybe it does a different one, maybe you will specify that interface to like ETH0, right, or whatever it may be, and then set the L port to like something weird. So we can do run or exploit. Let's do exploit. So here it did a check. So here did that auxiliary, right, as a check, as I mentioned earlier. So it says it's likely vulnerable. So target is vulnerable. So it's connecting, it's trying to exploit it. It's performing the actual exploit here. And then once it exploits it, it's going to send that stage, right? So here it's sending egg. I'm not sure if that's part of the exploit itself or if that's part of the stage. I had to keep seeing here. But it'll eventually send that little bit of code to allow it to set up the reverse shell. And then once it's done with that, it will come back and establish that connection to the interpreter machine. So, looks like it's taking some time here. Okay, looks like it failed there. Sometimes with especially Eternal Blue, sometimes it can have some issues when it comes to trying to establish that connection. It is a known issue though. So, but yeah, so we completed the module. Yay, introduction. So, I'm gonna see if it does go through. If it doesn't go through, there's no harm, no foul. Um, but it would be nice to see it actually connect. Okay, maybe. Oh, I think yeah. What's the page? I don't remember how to get back. Or is it foreground one? Foreground console. I don't know. It's been a second since I used Jobs. Okay, there it goes. It's been a while. Okay, there we go. So yeah, it was just taking some time there, looks like. Okay, seeing a response. Looks like it didn't get that last time, right? No. From exploit packet. it doesn't do it this time, we'll just move on. It says it should be vulnerable though, so yeah, it would be best if you had use the target. So if it doesn't do it, then we will just move on. I don't think it's gonna do it. All right, and we can do show options again just to make sure everything was set to. Yep, yep. That was IP, right? 10, 193.90. Yep. We set like a different L port, possibly. We'll do both. Maybe it's actually looking for that. Actually, let me do. There's a tag Z to do in the background. Well, I'm gonna let this run. If it does it, it does it. If not, oh well. But I'll give it some time to try. Oh, maybe it crashed. It could be possible that it crashed, which is why it didn't do that. Because yeah, I think that's actually what happened. I think the exploit crashed it, which is possible, right? So what happens sometimes is, especially with Eternal Blue, is very well known to that it will crash. So if you're not actively doing, um, if it doesn't do it properly or whatnot, it can definitely crash and cause some problems. So as earlier, it was saying it was vulnerable. I can scroll up and see. Oh, there we go. Where are we at? So here, host is likely vulnerable. Scan 101 complete. Target is vulnerable, and then now connection timeout. So looks like the exploit crashed the machine, which is probably why it was not working. So cool. We can terminate that. Sorry that it did not work, but it does happen. That's why you have to be very careful when you are exploiting these machines, because if you aren't careful, then if you're trying to attack a very high target, then you crash it, then well, that's kind of playing your cards, right? So I'm gonna take a small break, and then I will jump into this next module. Okay, I'm back. Took me some time to just go eat some breakfast with my wife and going walking the dogs and spend some time with them. So we are now onto the next module of Metasploit exploitation. So using Metasploit to scan, do some vulnerability assessments, and some exploitation stuff. Already got the machine started up here, so this looks like it's going to take about 25 seconds to boot up, so should be plenty of time. So, in this room, we will learn how to use Metasploit for vulnerability scanning and exploitation. We're also going to cover how the database feature makes it easier to manage penetration testing engagements with a broader scope. Finally, we'll look at generating payloads with MSF Venom and how to start an interpreter session on most target platforms. So, more specifically, the topics we are going to cover are how to scan systems using Metasploit, how to use the Metasploit database feature, how to use Metasploit to conduct a vulnerability scan, and how to use interpret. Oh, excuse me. Sorry, I was looking all around. How to use Metasploit to exploit vulnerable services on target systems, how MSF Venom can be used to create payloads and obtain an interpreter session on the target system. Please note that for all the questions that require using a word list, so brute force attacks, we're going to be using the word list on the attack box found at this path. I've already downloaded those files, so we're going to go there. So let's go on ahead and move on. So we have our IP address. So Metasploit has a number of modules to scan open ports on the target system network. You can list potential port scanning modules available using the search port scan command. So that's pretty good information there. So here they did some port scan searches. So we got WordPress, some firewall stuff. We'll also require you a few set options. So looks like they do the scanner, set delay, the jitter, ports, the target obviously. So a couple of targets there you can or settings you'd have to set up. So yeah, we can take these notes also for our port scan. So concurrency is the number of targets to be scanned simultaneously. Ports are the port range to be to be scanned. Note that 1 through 1000 here will not be the same as using mmap with the default configuration. Mmap will scan the top 1000 most used ports, while Metasploit will scan port numbers from 1 to 10,000. Our host, target, or target network to be scanned, and then threads. The number of threads will be used simultaneously. More threads will result in a faster scan. You can directly perform mmap scans from the MS prompt as shown below faster. So here they did mmap, they did a self scan on this IP, and it looks like they got this information. As for information gathering, if your engagement requires a speedier approach to port scanning, Metasploit may not be your first choice, but a few number of modules make Metasploit a useful tool for the scanning phase. So UDP service identification, so you could use a scanner discover UDP suite module, which will allow you to quickly identify services running over the UDP protocol. As you can see below, this module will not conduct an extensive scan of all possible UDP services, but also it does provide a quick way to identify services such as DNS or NetBIOS. So it's a good one to keep in mind. Looks like here they ran it, 13 probes to this IP, and they discovered this NetBIOS. Yeah, looks like that's all they got from it. There's some SMB scans. SMB, if you remember from our previous lessons, is mainly a Windows thing, but it is possible to have on Linux for like Samba and stuff. So using SMB scan here. Useful in corporate network would be an SMB and num shares and SMB version, but please spend some time to identify scanners and Metasploit version installer your system offers. So here they ran the version and found out that, hey, this looks like a Windows 7 professional source pack 1. This is some of the information like that. When performing search scans, it would be important to not to omit more exotic searches such as NetBIOS. NetBIOS, a network basic input-output system, is similar to SMB, allows the computer to communicate over the network to share files or send files to printers. NetBIOS name of the target system can give you an idea about its role or even importance. So Corp DC, DevOps, sales, etc. Right? So you may also run across some shared files and folders that could be accessed either without a password or protected with a simple password. So something like admin, administrator, root, tor, etc. Remember, Metasploit has many modules that can help you have a better understanding of the target system and possibly help you find vulnerabilities. It is always worth performing a quick search to see if there are any modules that could be helpful based on your target system. So, how many ports are on the target system? You can use a port scanner module on Metasploit. So let's do that now. So search port scanner. So we can do use 0. We can do show options here. Okay. So we're gonna set our host to. Okay. I see. So because I copied it earlier and then I was copy pasting stuff. That's why it copied all that. So let me do this real quick. There we go. That's what I wanted. So let me just see if it did anything weird with that. Okay. Okay, cool. So yeah, I mean, let's just run it. See what we see. Okay. Wait, separate. Didn't it want something else for port scanning? There's a port scan. If I dislike that. Okay. I thought there was like a very specific port scan module. Okay, scanner port scan TCP. So, so this guy. So use 173. Let's try that guy instead. So show options. Our host to options. Okay, and now let's run it. Okay, so we see 1, 2, 3. Looks like we got 3 so far. Oh, 4. Cool. So it looks like they have FTP, Secure Shell. Uh, 139 is what? RPC, and 445 is usually like your SMB. So, okay, that makes sense. Let's see. I'm gonna go and see if maybe that's the number. We can obviously wait, right? Okay, so it doesn't look like it's that. It looks like there's something else. It does take quite some time for port scans to be done, so we'll move on. Using the relevant scanner, what net BIOS name can you see? What is running port? Well, if there's port 8000, I'm going to take, maybe that's 5. That's the 5th port. So we'll let this keep running. Maybe it can capture that, and once it captures that, then we can close out the port scan. Normally, right, if we're doing an actual pen test or something, or being a bad guy, we would probably let this sit there and scan for hours, maybe even days, depending on how much information we want specifically. So, okay. SMB wordless. Okay. So, well, this is just going to tell me with the ports are open, so we can go ahead and close that. So, using relevant scanner, what net BIOS name can you scan or see? So, let's search for net BIOS. Okay, net BIOS information discovery. That looks pretty good to me. It's show info, right? Okay, so looks like just auxiliary scanner looking for discover information about net BIOS. Okay, so show options here. We'll set our host to the IP address. So we don't have 137, right? So let's set our port to 139 and show our options again, just to make sure. All right, let's run it. And remember, we set this to 139 because the default port was 137, but with NetBIOS and RPC and all of that collective whole, it does like that 13789 range. So when we were doing the scan, where is that? Right here, we saw 139, so that's how we're like, okay, let's run there. Okay, we can try 137. Let's see. But again, it wasn't open, so, or at least maybe it was hiding it from us. So using NetBIOS MB name module. Yep, that's the one we're running. Oh, on target port UDP. That makes sense because we did a TCP scan, so that'd make a little bit more sense why I wouldn't capture it on the 139. Okay, so we got Acme IT support. We got this, other information. So, okay. So we'll go and throw that. What is running on port 8000? Use the HTTP version module. Okay. So search HTTP scanner. And it mentioned what type of module? HTTP version. Okay. Let's do actually set scanners. HTTP version. Okay, there's some version there. So also, if you haven't noticed, the search it usually is in alphabetical order, so that's a good way to help you find maybe what you're looking for. Okay, so there we go. So we can use 0 info. Cool. It says version information about each system. So we're gonna set our host to, oh, that's not the right guy. To let's get the IP again. So set the R host to this guy. Set the R port, because again we're not using 80, we're using 8000. Show options again. Cool. Let's run it. So it looks like we got some 434-bit error. So maybe this WebFS 1.21. And then what is the Penny user SMB password? Use the wireless mentioned in the previous task. So use the SMB login module. So let's go and look at that. So search SMB logon. Use 0. Decrease. Oh, okay, cool. So show options. So here, there's quite a bit here. So we're gonna set our host again to, what was the other IP? This guy. Okay. Okay, SMB port, yep. So we're looking for the SMB password for Penny. So we know the user, so SMB user Penny, right? It's not lowercase, or it is lowercase, okay. Set SMB pass, or actually user pass file. And the way we can do that is we can cat Metasploit. Here, I'll do it in another terminal. That way we can keep it clean. So we can cat Metasploit here. So as you can see, it's all in one line. So we're going to be using the user pass file containing user password separated space, one per line. SMB pass. Probably SMB pass. We should be able to get away with it. If not, we may swap it up. So set SMB pass to, I think it's what, file. Our targets list and one target. So file colon path the target file. Okay, so path. So present working directory. We can get this. That's not what I wanted to do. And then the name of the file, which is this guy right here. Is it tab? Oh, okay, it does tab. Cool. So, cool. Show options. Not sure if this is going to work the way it's intended, but we can try it. Okay, yeah, I didn't think so. Alright, so let's do this. So, search, exploit, use 6352, right? And then search SMB login, use 0. Show options. I got, what was it? Unset. Think of it as clear or unset. Unset all. Try that. Show options. Okay. Now we're back here. Set our host to the IP again. Grab that. Okay. So let's see. Password, username. Set SMB user is Penny. see it says username, user underscore file. I don't see a pass underscore. Oh, there it is. Pass underscore file. Okay. Set pass underscore file to file, and then we'll do home. This is not. Okay, let's try running it now. Okay, there it goes. So, as you see, it is trying to brute force this SMB logon for Penny here. So it's just going through all the possible potential passwords. I guess where I was messing up at was I was seeing this user pass file too, and so I was like, oh, maybe that's what it wants, or even the SMB pass of like if I supply it to a file saying, hey, file, here's our word list, like it did with the one of them we were looking at up above. I think it was with the port scan actually, when we were looking at that for, hey, if we're supplying a file, I can actually try looking for it real quick. See, you can use a file where targets are listed, one target per line, and so that's where we try set our host file, but I guess that may only be the like IPs or things of that nature. So okay, so it looks like Penny Leo1234 is the password. Leo1234. Sweet. Excuse me. So, while it's not required when interacting with a single target on TryHackMe, an actual penetration testing engagement will likely have several targets. So, Metasploit has a database function to simplify project management and avoid possible confusion when sending a parameter values. You'll first need to start the PostgreSQL database, which Metasploit will use with the following command. So, system ctl start postgre. So, let's try that. So, let's go over here. Oh. Okay, let's do sudo bang. Okay, there we go. Then you will need to initialize Metasploit database using msfdb init command. Okay, so msfdb init. Oh, sudo bang. So we'll let that go. And so you can now launch MSF console and check the database status using the db underscore status command. So let's close this one out. So console. And we'll let that run back up. So we'll copy this information here. So actually, let's do this, and then okay. So that's back up. Cool. Oh, that's kind of cool. Cyber missile command. So here we ran the database. So now we can see the DB status. So DB status. Connected MSF. Connection type. Postgre. Cool. Database feature will allow you to create workspaces to isolate different projects. So when first launched, you should be the default workspace. You can list available workspaces using the workspace command, and I'm pretty sure we got that one right. Yeah. So we can do workspace. You can see it's the default there. You can add a workspace using the tech A operator. So workspace tech A, or you can use tech D to delete it. So they did tech A, TryHackMe, you know. So we could do that. So we'll do TryHackMe as well. Cool. And then we can do workspace and see that we're on the TryHackMe one. You'll also notice that the new database name is printed red around the star symbol. You can use workspace command to navigate between your workspaces simply by typing workspace followed by the desired workspace name. Okay, you can use the workspace tech H command, and this is lists available options for the workspace command. So workspace tech H looks like kind of like a help menu here. So you can add, delete all, help, list, rename, etc. So different from regular Metasploit, once Metasploit is launched with a database, the help command, you will show the database backend's command menus. So here we can type in help, and there's the database backend. Alright, if you run an nmap scan using the db nmap shown below, all results will be saved to the database. It's also a really nice thing to do there. So we can save all of these to the database and keep it kind of isolated from each other. You now receive information relevant to hosts and services running a target system with the host and services command respectively. So, okay. So let's try that, right? So what's our IP again? Up here, 10.10.229.248. Okay. So db underscore nmap. So db underscore nmap. And we'll just do a quick stealth scan. Okay, so found all these things, and so now we can look at hosts rather. See, this is the IP, and was it services? Yep. So services, we can see. Okay, so 248 has these ports open. Gives us the name and information about it. So that's really helpful. The host H and service H commands can help you become more familiar with the available options. Once the host information is stored in the database, you can use the host attack R command to add this value to the rhost parameter. Okay, so we'll copy all of this. This is pretty good information. So the way this would usually work is we will use a vulnerability scanning module that finds potential turn blue vulnerabilities, right? So we're going to use the auxiliary scanner SMB command, right? Set the R host value using host tac R. We have type show options to check if all values were assigned correctly. So, for example, their IP, you scan early using the DB nmap. Once all the parameters are set, we can launch the exploit using run or exploit commands. So here you see it, host tac R. Now host is going to take that IP address, and you can do show options, and you can see that there it is, and they run it. If there is more than one host saved to the database, all IP addresses will be used when the host tac R command is used. In typical penetration testing engagement, we could have the following scenario: finding available hosts using the dbmap command, scanning these for further vulnerabilities or open ports using port scanning module. The service command can be used with the attack S parameter while you search for a specific service in the environment. So here they did services tac S, and then they said NetBIOS, and it showed them what had NetBIOS. So we can do that here. So services tac S FTP, and we can see, oh hey, this guy has opened FTP. So that's actually pretty awesome that we can have that all in one, and we can actually kind of go back and forth with it. So this other, like it says, low-hanging fruits. So HTTP, potentially a web application, we can find vulnerabilities like SQL injection or RC, remote code execution. RTP could allow anonymous login and provide access to interesting files. SMB could be vulnerable to SMB exploits like MS-17. SSH could have default easy to guess credentials. RDP could be vulnerable to blue keep or allow desktop access if weak credentials were used. So Metasploit has many features to aid in engagement, as such as the ability to compartmentalize your engagement in workspaces, analyze results at high speed, and quickly import and export data. Metasploit also allows you to quickly identify some critical vulnerabilities that could be considered as low-hanging fruit. The term low-hanging fruit usually refers to easily identifiable and exploitable vulnerabilities that could potentially allow you to gain a foothold on the system and in some cases gain high-level privileges such as root administrator. So finding vulnerabilities using Metasploit will rely heavily on your ability to scan and fingerprint the target. The better you are at these stages, the more options Metasploit may provide you. So if you identify a VNC service trying to target, you may use search function on Metasploit to list useful modules. The result will contain payload and post modules. At this stage, these results are not very useful as we have not discovered a potential exploit to use just yet. However, in the case of VNC, there are several scanner modules that we can use. So they say, hey, I scanned something, I saw VNC was open. Cool, let me see if there's a scanner out there for VNC. And you see these different ones, and so they say, hey, I want to use this VNC scanner. And then you can also get the info to understand kind of why or when you would use this. So as you can see, the VNC login module encompasses fine login details for VNC service. So who wrote the module allows us to check SMTP service for Open Relay. So let's look that up. So search Open Relay. Okay, so that didn't work. So let's do search SMTP. Oh, STMP. SMTP. Okay, so I see this guy. So info 39. Just a SMTP server will accept an email using various testing method. Okay. Open relay detection. Yep, looks good to me. So Campbell Murray. Okay, so it looks like this may be a different machine here. So I'm going to terminate this guy. I'm going to start this one up. So, as the name suggests, Metasploit is an exploitation framework. Exploits are the most populated module category. So, here's some version details about it. There are 2,048 exploits, looks like, on this. So, a lot more than everything else listed. You can search exploits using the search command, which we've done. You can also get information about the exploit with info command and launch exploit using exploit. So, while the process itself is simple, remember that a successful outcome depends on a thorough understanding of services running on the target system. So, most of the exploits will have a preset default payload. However, you can always use the show payloads command to list other commands you can use with a specific exploit. Okay, so here they have this exploit and they're doing show payloads to see what else is useful with it. So we do search or type exploit. We'll use 5730. Okay, so we see some type of remote code execution. So let's show payloads. So there are 634 payloads that would work with this exploit. So once you decide that payload, you can then use that payload to make it your choice. So here they did show payloads. They set their payload to number 2. So this is generic shell reverse TCP. And then they show options, and you can see the exploit options that you need, but also the payload options you need. So as you see, choosing a working payload could become a trial and error process due to environmental or other restrictions such as firewalls, antivirus, file writing, or the program performing the payload execution is available. Some payloads will open new parameters that you may need to set. So running the show options command once more can show these. As you see in the above example, reverse payload will at least require you to set the lhost option. That makes sense because it has to get a reverse shell back to you to allow you to connect. So here they set their local host, they exploit it, they start it, it goes, runs, and then it opens this session 1, which earlier when we were trying to get that, it never worked for us, sadly, but it would open the session up, and then this is what you would see. So once the session is opened, you can background it using Control Z or abort it using Control C. Backgrounding a session will become useful when working on more than one target simultaneously or on the same target with a different exploit and or shell. So the Control Z says the background it, they say yes, and then here is added into their sessions. And you can see the connection here from the local IP here to this remote IP. So sessions lists all those active sessions. Command supports a number of options to help you manage sessions better. So you have sessions tag H shows you all the different options you can run with it. And then you can interact with any existing session using sessions tag I. So you can do sessions tag I1, and now you're back into that original shell you were in. So deploy the machine, answer questions. Exploit one of the critical vulnerabilities on the target VM. So let's back. So I liked to do the DB thing because that was actually really cool. I don't know if it mentioned if there's a way to clear the DB though. So we'll do just help. So let's see here. So there's DB underscore remove the save data service entry. Okay. But we could also just create another workspace too, right? We can make a workspace and go to that one, and then that should make it clean slate. So let's do workspace, tag A, section 2. Okay. And then we can look at workspace. We see your section 2. And then, what was it? DB, mmap, DB status. So DB status. Cool. So still see that we're there. And then it was sessions tag R and host tag R. Cool. So let's go back up, get this IP. So DB, once we're in map, let's paste this guy in here. And we'll try sudo and ss. Okay. So okay, so that's actually neat. So you request the scan requires root privileges, so it runs it with sudo just for you. Because I tried running sudo with it because I knew to give me this error, but it automatically does it for me. So it makes it a lot easier actually to run those scans. So we're gonna run the scan, see what we can find, and from there, then we can try to find some type of module to exploit that vulnerability. So DB nmap. There's also service, tech S or specific services for the environment. Tech R. So it looks like it may take a couple of seconds. So 10, 130, 190. Just make sure that I did get the right one. Yep. Okay. So I'm gonna let this do its thing, and once it gets done, I'll come back. Okay, so it just finished. As you see, we have all of these different ports open that we can try looking at and trying to exploit. And then again, just make sure we now see this the host, and then we can do services tech R and see all the different services available. So we see 135, 139, so some RPC, NetBIOS, and some SMB stuff. So if it's SMB, SMB is usually a very chatty service. So let's just look up some type of SMB scanner. Okay, let's do scan. See if that gives us something. Okay, so we'll use number 25 to get that SMB version. Make sure that our stuff is going to, actually, good night, I need to type. get what we're trying to get to, right? So we're gonna set our port to 445, and we're gonna run this right here. And also, as you see, it automatically chose our R host for us, so that was really cool. Okay. So looks like it detected the SMB service. Great. Version 1 or 2 looks like. So okay, some domains. So John PC looks like Windows 10 Professional. Okay, that looks like it might be susceptible to Eternal Blue there. Running SMB. Yep. Cool. So it looks like they detected 2 different services, maybe 2 different instances of it, possibly. Or maybe it just gave it to me twice. Okay. So we saw that. So just to make sure, let's do 5 here. Okay. Show options. Okay, that's what's the username password. Okay, we don't have that, so can't do that one. 17. Use 0. Show options. Okay, maybe it doesn't. So let's do info. Make sure. Sometimes return to blue. Automatic target. May not trigger 100% of the time, but should be run continuously until triggered. Okay. By default. Okay. Now, some systems may cause system instability and crashes, such as a BSOD or a reboot. Maybe like with some payloads. So let's just see, just real quick. Target is missing the MS17010 patch. Great. So that definitely helps out with some intel there. So it looks like this is probably the guy that we want to run. So we're going to set our L host. It's probably, yeah, see, this is where it's like, so we have the loop back. We have the tunnel. Let's just do the ton 0. There we go. All right, and then we can just leave, I guess, the local port as 444. So show options. Okay, looks good, looks good. Let's run it. Okay, so it just ran the check just in case for us. It says, hey, it is vulnerable. Conducting a connected target for some exploitation. Trying to do the stuff, seeing some buffers. Oh, there you go. We're seeing the stage. So again, remember when we send that stage, because the payload, it's a stager, it sends that little bit of code to it. And so once it gets done, it's like, okay, cool, exploit's done. Let's actually call back, and then we have a interpreter session opened. So great, we got the vulnerability exploited. What is excuse me? What is the content of the flag.txt file? So what we can do is we can drop into a shell and get onto the system. So as we see, we're in the Windows System 32. This is all the fun stuff on the Windows System 32. So let's go back. We can do the same exact commands as you normally would on Windows. So maybe if we go to users, dir, go to John, see what's on John's stuff. Go his desktop. Okay, nothing there. Let's see if it gives us a little use interpreter search command. Okay, so it actually says to use search. Yes, for background. So let's look at the help. Excuse me, sorry guys. So let me scroll up, just make sure I see everything here. So this is search. Is there a search? And because this is, yeah, okay, yeah, search for files. Cool. So interpreter, it has its own command line that you can use. So we're gonna see if we can search for, oh, it's like that. So it looks like we're looking for some flag.txt. We'll let that run. I'm not 100% sure where that actually searches from. If it searches from the highest level and then it goes down, or if it searches for your present working directory. So we'll we'll see what it finds for us. But as you can see, there's some core commands here that it likes to do. So you can like pivot to a different service or migrate to a different service. Um, so there's a couple of things there, right? You can see your different sessions, some file commands, basic Linux commands here. So you searching for this file we're trying to do. You can upload files to it, right? You have some networking commands as well. So viewing, modifying route tables, ARP caches, and their interfaces. You have some system commands. So probably the um, biggest one maybe is maybe if you get privs, enable all privileges available to the current process. Maybe if you want to execute a command, get your priv right now. Different things of that nature. You can do some other enumeration. It looks like some unum desktops. So some just user stuff. Maybe you could dump the keystrokes. Maybe you want to sync key events. Grab a screenshot. That's interesting, right? Webcam, get some pictures. You can play some audio cues if you wanted to. Mess with them. You got a get system. This is probably another really cool utility in Metasploit, is to actually attempt to elevate your privilege on your system. So whatever you are, whatever your position is or your role in the account that you are in, if you are not, the highest level of NT system or root, then maybe you can prevesc using get system. You can do hash dumps here, getting the contents of the SAM database, always useful. And then you can time stomp to crash out those logs to make sure that they can't track you down. Alright, so it found the flag in this path. So now, with the help, we can just go to that file. Let's just go to that file. We'll make it easy. So let's cd to C, and it is users John documents. Alright, I'm gonna dir here. There's a flag. Can we flag a text, or is it going to want us to do it? Yeah, okay, just thought. So I think it's what? Type flag.text. And there it is. Sweet. So what is the NTLM hash of the password of the user pirate? Use hash dump. Oh, sweet. So again, we can go and back out of this. So okay, I didn't know if it would read that or not. So we background it. So now we can do hash dump. We can gather the hash. So here we see all the different users, and so we can take this, copy, paste. Oh, did I copy? Yeah, I think I did. I was like, where? Okay. The NTLM hash, is that not it? Because like, it won't let me paste the entire thing. I don't think. Yeah, so let me paste the entire thing. Yeah, it's looking for that hash too, so. Is it one on the back side of it? Okay, yeah, I just wanted the back side of it. So cool. So there it is. If I may run help again, so I'm pretty sure you can get files from, download a file or directory. So if we wanted to, for earlier, right, what was the path? It's all the way up here. So here. So we could try download. I think it wants the escape characters too. Yep. So it wanted escape characters. So now if we wanted, now we have cat, flag.txt, and there it is. So just something cool. I just want to show off that Meterpreter can do. It's a very powerful framework. Okay, so I'm going to terminate this machine and go on to the next one. And so because of that, our Meterpreter shell will sadly crash. So we can background this if we want to, but we will see eventually that this session will go away. Alright, I'm going to exit the split view there. So MSF Venom. So this is what replaced MSF payload and MSF encode, and this is what allows you to generate payloads. So MSF Venom is going to allow you to access all payloads available in the Metasploit framework. MSF Venom allows you to create payloads in many different formats. So you have PHP, EXE, DLL, ELF, Excel, etc. Right? And it's for many different target systems. So if you want Windows, Apple, Android, Linux, anything and everything, it has different kinds of payloads for it. So you have output formats. So you can either generate standalone payloads, so Windows executable from Interpreter, or get a usable raw format, so like Python. The MSF Venom tacticalist formats command can be used to support formatted output formats. So let's throw that in our notes here. Encoders. So contrary to some beliefs, encoders do not aim to bypass antivirus installed on the target system. The same suggests they encode the payload. While it can be effective against some antivirus software, using modern obfuscation techniques or learning methods to inject shellcode is a better solution to the problem. The example below shows the usage of encoding with the tag key parameter. The PHP version of Interpreter was coded in base64 and the output was raw. So here, let's set MSF Venom tag P, so the payload here of PHP versus TCP, the local host to come back to, the file format is raw, and then the tag E here is encoded with PHP base64. So we'll take this and add that to our notes as well. So handlers, similar to exploits using reverse shell, you will need to be able to accept incoming connections generated by the payload. So when you're using an exploit module, this part is automatically handled by the exploit module. Remember how the payload options title appeared when setting reverse shell. The term commonly used to receive a connection from a target is catching a shell. Reverse shells are interpreter callbacks generating your MSF Venom payload can be easily caught using a handler. So, following a scenario may be familiar. We will exploit the file upload vulnerability present in DVWA. I'm not going to say that word, but vulnerable web application. For the exercise in this task, you will need to replicate a similar scenario on another target system. This was here for illustration purposes. The exploit steps are: generate the PHP shell using MSF Venom, start the Metasploit handler, execute the shell. So, MSF Venom will require payload, the local machine IP, the local port to which the payload will connect, seen below. The IP is IP of the TAC box used in the TAC, and local port for Quad 7 was chosen. So, the payload, the host, the port, the file format, and then the file. Please note, the output PHP file will miss the starting PHP tag committed and the end tag as seen below. So here they didn't start with the PHP tag, so it got commented out. The reverse shell PHP file should be edited to convert it into a working PHP file. Below, comments removed from the beginning of the file. So here they had these comments, and they removed it. Below, end tag added. So let's copy this. Copy like this. So we take this image, and then we take this image, and take this image. So again, when it was created, it had these comments there for the PHP, and it didn't have the comment tag removed. So they went in, they removed those comments, and then they added that final tag in to make it a true PHP file. Then they're going to use multi-handler to see the incoming connection. This is the exploit slash multi slash handler command. So this supports all of the Metasploit payloads, can be used from interpreter as well as regular shells. So to use this module, they're going to set the payload value as PHP slash reverse underscore PHP in this case, the whole L host and L port. So they use the exploit. Their payload is set to this, right? And then, because every exploit has to have some type of payload with it, so even though the exploit is a multi-handler, it still needs that payload for that reverse shell. And they set the local IP, the local port to call back on, and so once that script is ran, and once you have your multi-handler running, and that script is ran and executed, it will call back. If the payload is set as interpreter, e.g. in a Windows executable format, multi-handler would then provide us with a interpreter shell. So, other payloads. Based on target system configurations, OS, install web server, install interpreter, etc., MSF Venom can be used to create payloads in almost all formats. Below are a few examples you often use. And the examples, lhost will be the IP address of your tagging machine, and L-port will be the port in which your handler will listen on. So, all of these are very, very, very important. Especially, I had some funny instances here of the .elf working in real life with the creating an MSF Venom payload and understanding how that worked for Linux machines. Because normally you'll see exes for Windows, and that's the big one you hear of, but you don't really hear a whole lot of .elfs out in the wild. So, but .elf is the Linux executable and linkable format. So here, same thing. They did the P, the Linux version TCP, the host, the port, the file format as ELF, and then the file name. So the .elf format is comparable to the .exe format in Windows. These are executable files for Linux. However, you may still need to make sure they have executable permissions on the target machine. So once you have the shell.elf file on your target machine, use the chmod +x shell.elf command to accord executable permissions. Once done, you can run this file by typing ./shell.elf on the target machine command line. And then, classic windows.exe, php.php, .asp.py. All the examples above are reversible payloads. This means you will have the exploit multi-handler module listing on your tag machine to work as a handler. You will need to set the handler according with the payload, lhost, and lport parameters. These values will be the same you have used when creating the MSF Venom payload. Alright. Watch the VM attached to this test. The username is Murphy, and the password is that. You can connect via SSH or launch this machine in the browser. Once on the terminal, type sudo su to get a root shell. This will make things easier. So, let's go on ahead and do that now. Let's grab the IP. Sweet. So, username is Murphy. So let's go over here to Murphy. So it is 1Q2WE. Okay, so it's just... Okay, got it. Sweet. So I'm in. So again, we can do sudo tech-l, right? Oh. Sorry. So again, you can do sudo tech-l to see what permissions your user is running as. So here it is all. So we can do sudo su. So this is us saying, hey, we want to switch to the root user. And because we have the ability to run commands as all for sudo, we can now get to the root. So create interpreter payload in the ELF format. So let's go over here. We'll open a new tab. So the Linux executable here. So let's go and take that, make it a little bit nicer and neater. So we'll paste this bad boy here. So let's go over here and fix our L host. So it's 2.19.222. We'll say our port for this guy is 4765. Okay, and we'll just keep it like that. Make it super simple, easy. Okay, sweet. And then we're going to search. Actually, we could just use, right? Because we already know this. So payload, and then set, search exploit or type exploit multi-handler. Use 6. Show options. Okay. So you have our exploit here. Oh, I see. I think I did. Yeah, I had to set payload. Am I tripping here? So we used the exploit, but then we had to set our payload. Show payloads. I thought it was set payload, right? Because if I do use, it's going to change it. So, like, for example, use 1398, right? Set payload. Show payloads, yeah. Because that's what we just did, right? We just did show payloads. So set that's for something else. Okay. One three nine eight. Yeah. So why was it giving me errors with the other one? Oh, was it because I did this? Oh, I see. I did set payload as in this. I didn't put the payload specifying. Hey, set payload. Did the payload name? Got it. Okay. I was like, what is happening here? All right. So we have the payload of this. So set lhost. We'll do. I think it's times 0. Yeah. Okay. And then set lport. If we remember, it was what? 4765. So 4765. And we can do show options again. Cool. We'll run. And once we run this, it should say starting TCP handler. Cool. Transfer it to the target machine. You can start a Python web server and tag machine with Python 3. And use wget to download to the target machine. So let's try that. So let's do wget or Python 3 tag m http.server. On port 9000. So then we'll do wget. Oh. Hello. My it's like my SSH isn't working. Okay, let's try it. Was it Murphy? I don't remember the IP. Was it? Remember it is. Yes. 'Cause I'm pretty sure it's Murphy, right? Yeah, Murphy. Okay. Is my box not working? Let's cancel the shell right now. I think maybe my... Yeah, I think it's the terminal again. I don't know why it's done this again. Okay, I'm gonna terminate my machine and I'm gonna restart it because it looked like maybe something happened and it just crashed. I really don't know. So I'm gonna wait a minute and then we will continue on. Okay, so I tried it a couple of times of trying to close out this SSH, reconnecting, trying to get that to work. I'm not sure why it's not wanting to work for me. So I pulled up the screen view here for the actual box that we're trying to attack. So I'm just gonna do it this way instead. So let's see if this works. Okay, that's what I thought. So let's cancel this. I'm here. So let's try, because it's saying to do the HTTP server, and to get this looks right to me. So let's do 10 to 19. Yep, that's it. Don't really know where it's coming in at. So let me see what it looks like. So 2.19222. Okay. Because it should be coming in, and it sees it's coming in. It's just not actually able to grab the file. I'm in the right directory for it. HTTP attack me underscore machine underscore IP 9000 shelf.elf. Yep, that should be it, because I'm pretty sure that's what's... Oh, it's not named that. That's why. Rev underscore shell dot elf. Okay, that might be why. Let's try that. Okay. Oh, let's get rid of the desktop just in case that's what's causing it. There we go. Okay. I was like, I'm not sure. So I've had some issues in the past, just personal training range stuff, where I would do Python servers and I would do in the desktop, and then sometimes I would do some weird wonky locations like at the root directory. I'm like, oh, that's not where I wanted it at. So looks like the issue here was I was asking for the wrong file, and then as well as I was specifying desktop, but I was hosting the Python at the desktop. So I think that's why it was working weird. All right, so we can do ls now. We can see the rev shell.elf. So let's do on rev shell. So it looks like there's no execute. So let's go on ahead and do, oh shoot. Let's make it wide open, right? We'll go and get that going. So we'll go back. So we have our Python. We can close that out. Let's set up our multi-handler. We can close this out now. So we started the first TCP. So we're going to go back. We're going to execute rev shell. And it looks like it's hanging, which is a good sign for us. And send the stage, and we got the session. Let's go. So use a post exploitation module to dump hashes of other users on the system. Use the post Linux gather hash dump. So we can just do Control Z here, background the session, and just make sure we have all these different sessions, and it's there. So search, type, post, remember, because we already have a session. We're trying to do more onto that session. And we do hashed up. We are on a Linux machine here, so we're going to use 3. And we're going to do show options. And we see, okay, we want to set our session to 2. And show our options again. Make sure. Great. Let's run it. So this module, this post module, is going to do a hash dump onto the Linux device, trying to get all the hashes, and there we go. What is the other user's password hash? So not Murphy, but we have Claire. So we have all of this right there. Sweet. So you should now have a better understanding of how Metasploit can help you identify potential vulnerabilities on target systems and exploit those vulnerabilities. You've also seen how the database feature can help you with penetration testing engagements where you have multiple potential targets. Finally, you should have gained some experience with MSF Venom and the creation of standalone interpreter payloads. This is especially helpful in situations where you can upload a file to a target system or have the ability to download the files to the target system. Interpreter is a powerful tool, offers a lot of easy to use features during the post exploitation phase. And come on, there we go. Sweet. And we completed our room. So we can go and terminate this machine now. Sweet. And if we look now, we have 2 more modules left. So let's see how long they are. Don't want to make this video too long, so 20 minutes, 30 minutes. We can try pushing on forward. So, all right, let's see if there is a machine. There is. Let's just go ahead and start it. Let it get going. And we can go in here. We can remove the Metasploit and remove the rev shell. Sweet. That's all good to go. We can back sessions. Cool. So, introduction to Meterpreter. So, Meterpreter is a Metasploit payload that supports the penetration testing process with many valuable components. Meterpreter will run on the target system and act as an agent within a command and control architecture. So, you will interact with the target operating system and files and use Meterpreter specialized commands. Meterpreter has many versions, which will provide different functionalities based on a target system. So how does it work? It runs on the target system, but is not installed on it. It runs in memory and does not write itself to the disk on the target. This feature aims to avoid being detected during antivirus scans. By default, most antivirus software will scan new files on the disk, so when you download a file from the internet. Meterpreter runs in memory, so RAM. To avoid having a file, it has to be written to a DAS on the target system, meterpreter.exe. This way, Meterpreter will be seen as a process and not have a file on the target system. Meterpreter also aims to avoid being detected by network-based IPS, or intrusion prevention systems, and intrusion detection systems, by using encrypted communication with a server where Metasploit runs, your attacking machine. If the target organization does not decrypt and inspect encrypted traffic, so HTTPS, coming to and going out of the local network, so your IPS and IDS solutions, will not be able to detect its activities. While Meterpreter is recognized by major antivirus software, this feature provides some degree of stealth. The example below shows a target Windows machine exploited using the MS-17 vulnerability. You'll see Meterpreter is running with process ID of 1304. This PID will be different in your case, and we have used the get PID command, which will return the process ID with which Meterpreter is running. The process ID, or process identifier, is used by operating systems to identify running processes. All processes run in Linux or Windows will have a unique ID number. This number is used to interact with the process when the need arises, and if it needs to be stopped. So, you have get PID, and they see that their PID is 1304. If we list the processes, they can do the PS. We can see 1304 is spools. Where's it at? Spools sv.exe. So right here, and they're running as a system level, and not Meterpreter, as one might suspect. Even if we were able to go to a step further and look at some like DLLs used by Meterpreter, so the 1304, we still wouldn't find anything jumping at us. So like no Meterpreter.dll. So here they ran a task list. They're looking for PID equals 1304. And here's all the different PIDs, but still nothing that looks like interpreter alarmed you to seeing, hey, this is a interpreter on my system. Techniques and tools can be used to detect interpreter are beyond the scope, but section aim to show you how stealthy interpreter running is, and remember how antivirus software will detect it. It's also worth noting that interpreter will establish an encrypted TLS communication table or communication channel with the attacker system. So some of the flavors of it. Metasploit payloads can be initially divided into two categories: inline, also called single, and staged. So here, if we look at introduction Metasploit, which we've already done, and scanning exploitation of Metasploits, which I believe we've already done as well. As you remember, staged payloads are sent to the target in two steps. An initial part is stalled, the stager, and the requests the rest of the payload. This allows for a smaller initial payload size. The inline payloads are sent in a single step. Interpreter payloads are also divided into staged and inline versions. However, Interpreter has a wide range of different versions you could choose from based on your target system. The easiest way to have an idea about available Interpreter versions could be to list them using MSF Venom as seen below. So here, MSF Venom TAC lists payloads, and then they piped it into grep Interpreter, and so only output shows these. So here you can see all the different Interpreter payloads here for the payloads. The list will show Interpreter versions available for the following platforms. All of these, Apple, Android, Java, Linux, Python, Windows. Your decision on which interpreter to use would be based on three factors: the target, right? The operating system the target is running. Is it Linux, Windows, Mac, Android? Components available on the target system. Is Python installed? Is it a PHP website? Network connection types you can have with the target system. Do they allow raw TCP connections? Can you only have an HTTPS reverse connection? Are IPv6 addresses not as closely monitored as IPv4 addresses? If you're not using Interpreter as a standalone payload generated by MSF Venom, your choice may also be limited. So you know some exploits will have a default payload. As you can see an example below with MS17. So you run the MS17 and hey, configure payload is this as the default. You can also list other available payloads using the show payloads like we looked at earlier. You can also type in help, which you've done already. It'll show you the built-in commands, some tools, some scripting that Interpreter can provide. So if you run the help command, you can also see these different categories. Please note that the list above was taken from the output of help on the Windows version of Interpreter. So these will be different for your other Interpreter versions depending on what type of system or OS you're on. So here are some of those core commands already that we've already taken a look at. Again, if you run help, it shows all these and exactly verbatim what they do. Post exploitation with Interpreter. So help, right? It gives you a lot of valuable commands. As we've seen earlier, many different versions have different options available. So you can see what we can use, what we can't use. The get UID command will display the user with which Interpreter is currently running as. So this gives you an idea of your privilege level, maybe who you are or where you want to get to. Are you admin level like NT authority or just a regular user, right? And then you have the PS again, the PID column shows the PID information maybe you need to migrate to. So a common one you may see is something like LSAS. So LSAS is that Windows security like executable. So a lot of times people will try to migrate to LSAS here and do hash dumps that way, so that way they can prevent up or maybe they can pivot to other services. So migrate. Migrate is another process that will help Interpreter. So if you see a word processor running the target, so Word or Notepad, you can migrate to it and start capturing keystrokes sent to the user to this process. Some Interpreter versions will offer you the key scan start, key scan stop, and key scan dump command options to make Interpreter act like a keylogger. So migrating to another process may also help you have a more stable Interpreter session. So to migrate to any process, you need to type the migrate command followed by the PID of the desired process. So here, they're trying to go to PID 716, which is LSS. Hey, just what I mentioned, right? So maybe they're trying to get those hash dumps. So they went from 1304, which is down here, to 716. And if you see like the 1304, they're still a system. They still have the right authorities, but maybe they're trying to get something else from it, right? So Be careful, you lose your user privilege if you migrate from a higher privilege user to a process started by a lower privilege user. You may not be able to gain them back, so be cautious. And then hash dump. Already seen this already with hash dumps. This is how you can get those passwords from the SAM database, and then they're also stored in the NTLM format. So here, again, you can see that this looks kind of like an MD5 hash. Remember when we were in cryptography, but again, it is that NTLM. You can see by some of the common patterns. I believe the B43F is a good way, and then the AAD3 is another common method to detect different values for your um, NTLM. I'm not 100% sure. Don't quote me on it. It's been a minute since I've deciphered NTLM hashes if they actually have content in them or not. But I'm pretty sure there is a format. There's a kind of common format. It looks like it is actually that the AAD3B looks like that all stays right around the same there. So, and then here you can see that these two are different. So, or like the FFB31D. So, but yeah. While it's not mathematically possible to crack these hashes, you may still discover the clear text password using online NTLM databases or a rainbow table attack. These hashes can also be used in pass the hash attacks to authenticate to other systems that use these users on the same network. You can also use search, which we've done already for the flag.txt in the previous module. And then shell, again, we'll already use that to get to the shell. All right, moment of truth, post exploitation challenge. So, excuse me. I'm going to start the attack box or the machine. We've already done that. So, use missions such as get system and hash dump, provide important leverage and information for privask and lateral movement. Interpreter is also a good base you can use to run post exploitation modules available on the Metasploit framework. You can also use the load command to leverage additional tools such as Kiwi or even the whole Python language. That's actually a little neat tidbit. So, post-exploitation phase will have several goals. The interpreter has functions that consist in all of them. So, gather further information about the target, look for interesting files, user creds, additional network interfaces, and just interesting information, privilege escalation, and lateral movement. Once any additional tool is loaded using load command, you will now see new options on the help menu. So, example below shows commands added for the Kiwi module using the load Kiwi command. And so, if you notice, it loaded Mimikatz. So, Mimikatz is a very well-known credential grabber. So, very, very scary to see that running on your system. These will change according to the load menu, so running help after loading a module is always a great idea. So here you see all the different Kiwi commands. See retrieve credentials, Kerberos, so dumping, so very useful technology there. Questions below will help you have a better understanding of how an interpreter can be used in post-exploitation. You will use the credentials below to simulate an initial compromise over SMB. And so you're going to be using PSExec. So again, that's kind of pass the hash of known password or the hash. So we got Balin and password 1. Super secure. So what I think I want to do first is I want to create a new workspace. I found that that's probably my favorite thing that we have done for this lesson actually is leveraging workspace to get us somewhere different and get kind of separate from everything else, and being able to automatically throw in the remote hosts because I always forget the IP. So DB nmap, let's go on ahead, do cell scan. We're looking at 10.10.4.3 and we're in Cali there. And we will start going. So it just wants the computer name, the domain, name of the share, some hash. So there's quite a bit of information that it's wanting for us, but it's all good. We will get there. First things first, though, we enumerate. So as we can see, there's quite a bit of ports up in here. for this. So we do see DNS, some HTTP server, some Kerberos settings. So it looks like maybe like a domain controller, right? Some 135.139.445 looks like SMB is open. LDAP, that's also some lightweight directory access protocol, so some like user stuff, also indicative of a domain controller, and then some other things here. So it looks like we're probably working with some type of domain controller. And just to make sure, or we can see this is the device, and these are all the ports. Love that. All right. So I think the first thing we should do, because of wanting us to use this exploit Windows SMB, is let's go on ahead and do that, right? So let me copy it. So how else would we want to figure out if that's what we want to use, right? So there's another couple ways, right? We could have definitely enumerated SMB and see maybe is vulnerable to it. Or if we do know that, hey, this is the target that is maybe got exposed in a data breach and their username and passwords got compromised, and we know this business is the target that got that breach. Okay, now we can try using something like this. So let's set our SMB user. It is what, B Allen 1 or just B Allen. Okay, set SMB pass as password 1, right? Yeah. Sweet. And then we'll do set lhost to ton 0. We'll set lport. We'll do 8754. So show options. Sweet. So let's go ahead and run this. See if we can break in. Alright, looks like it's trying to authenticate. Okay, setting the stage. Looks good to me. Okay, come on. There we go. Sweet. So we got the interpreter session. So what is the computer name? So we can drop into shell, right? Let's also run in help and see if it can give us information about the system. So let's see here. Might just be useful just go ahead. Let's see. Sysinfo, there we go. Okay, cool. So we see that we got into a Windows Server 2019. It's got 7 logged in users. That's really great for us. So I think I didn't capture the A there. Okay. What is the target domain? So it looks like it's Flash. What is the name of the share likely created by the user? So let's see who we are first. So we are a system. Okay. So I want to see what is mentioning here. Okay, I see. So this actually wants to enumerate. Okay. So we're going to background the session. And now let's look up for enum share. Okay. Use 0. Show options. Okay. See what our session number is. Session 3. Session 2, 3. Show options. Run. Okay. We see a couple of shares here. And then what's the name of the share likely created by the user? So sysfalse, probably not it. Scripts, maybe, right? But speedster, that sounds pretty good to me. What is the NTLM hash of the JChambers user? Okay, let's go back. So sessions, remember, tag I. So now we're back in. So then let's try to see if we could do a hash dump. Sweet, actually worked. So JChambers. So we'll grab, I I think they wanted the back end of their hash anyway, so we'll try that. What is the clear text password of the J Chambers user? So there's a couple ways, right? We could probably use John the Ripper, right? Or we could do online hash checker. So let's do that. Let's see if it's already been compromised first before we start going and trying to crack it. If it's already out there, then usually that's a good sign, an indicator that, hey, maybe we can go ahead and um, just save us some time. So let's just go and throw this entire line up in there. Okay, so it doesn't want that, so we do know for sure that this is it, so okay, caches. Alright, so it looks trust no one. Okay, where is the secrets.txt file located? Alright, so we can search for secrets.txt, right? That's the file name? Yep. So let's search. I keep forgetting that, the TACF. But it keeps reminding me, so we're good there. So we're going to let the search for this file, see if we can figure out where it's located at. And then it looks like we find that file and we find the other file, and then we'll be done with this module. I feel like that one we kind of knocked out pretty quick. So it's pretty good. Let's see, while we're waiting, we got 4 here, 3 here, and then 1 more here. So we are cruising right along. So this may take a bit. So I know last time it kind of took us a couple seconds. So once it gets done, I will be back. Okay, so I went on ahead and got the secrets.txt and the other one, the real secret.txt too. So now we can go on ahead. We can download these. So let's pull it up. So again, I'm pretty sure we have to do the like that. I may even have to do something like this. Okay, sweet. And then we can do this guy too. So download. And then, so in case you're maybe wondering why I'm doing the 2 backslashes, they're called escape characters, these slashes are. And so basically sometimes what happens is whenever a program is ran, it will see these slashes and think is trying to take it like outside of the program. So something maybe like if you're doing Python, you may do like a \n to do a new line. So if you want to say, no, this is a literal slash, this is what I'm looking for, you would do another backslash there. And so it will be like, oh, okay, he's not actually saying to do C colon and then do something after that. He's saying C colon slash and then the rest of it. So we can now go to the desktop. We can cat our .text. So the flash is the fastest man alive. The Flash is the fattest man alive. And my Twitter password is gobblegook. Alright. And then they want the file path, so we can go ahead and copy that real quick too. Okay. And then secrets.txt. Alright, sweet. There we go. So that was the interpreter module. So that was the final interpreter sessions that we were going through. It is now finally time to take on Blue. So we're gonna deploy and hack into this Windows machine. So we'll clear all this out. We're going ahead, add us another one. We're gonna call this one Blue Ominous. we can see. There we go. Sweet. So there's a walkthrough, 20-minute long. Whew. So we're not going to look at that yet, but it's only 5. Hopefully not too bad, right? So start the attack box, right? Start the machine up. Scan and learn what exploit this machine is vulnerable to. Please note that this machine does not respond to ping. It may take a few minutes to boot up. This room is not meant to be a boot to root CTF. Rather, this is an educational series for complete beginners. Professionals will likely get very little out of this room, but beyond basic practice, as a process here is meant to be beginner focused. Art one by our members of Varg. That was really cool. I like that. Gives me the classic Nintendo game vibes there. Link to the ice sequel to blue. Oh, there's a sequel to it. Okay. Ah, that's actually really cool. So they've done a lot of work with this. This is really cool. This is a great job. Um, the virtual machine used in this room can be downloaded for offline uses. So hey, if you're interested in that, there are some downloadable offline rooms. Maybe if you are interested in learning more about pen testing, or maybe you're just bored one day, you want to have this, it's definitely there. So it looks like OVAs, so probably something like whatchamacallit, whenever you can go and just download, it'll have the entire package there and you can just put it onto your system. So definitely something to look at. Great job, team here. This is really cool stuff. All right. Scan machine. If you're not sure how to tackle this, I recommend the in-map room. Well, let's see. Let's get our IP. So there we go. As you guys know, I love me some DB in-map now. If I can type. We'll do stealth scan just that way it gets us as quickly as possible. I don't want it to be hours trying to scan something. So we're going to let that scan go. So we complete that hint. Okay, so they did a little bit more verbose here. Looks like they got some service versions, some very verbose information. They did some scripts, script vuln, target IP. So we can maybe try doing that stuff too as well. But in the meantime, we'll just see what we can get. So we'll get rid of the .text ones. There we go. Sweet. So yeah, we'll let that go. Once it gives us the IPs, then I will probably do another service version on top of that. Just like it mentioned, maybe try this just to go ahead and get something going. But at the very minimum, I would like to get a service version too. So while this does this thing, I will take and pause. Okay, so I canceled the scan just to see if maybe it was the box, because it did mention earlier that it may take a couple minutes. So I did a quick map on just another tab, and it was like, oh, found all these ports immediately. So I was like, oh, okay. So I canceled the other scan and just re-ran it. I went on ahead and just did the SV and the VV since I didn't know it was going to work this time. So as you can see, there is a lot of information we got here. So again, 135, 139, 445, that looks amazing. We see Windows 7, so it's a possible MS17 vulnerability. We can definitely check that out. We see 3389, so usually 3389 is remote desktop, but it says some type of web server. Didn't really understand what it was, so we had to look at it. We do see, so it says John PC, it's a Windows, so we do have a lot of information to work with here. So let's see. We got 1, 2, 3, 4, 5, 6, 7, 8, 9. Looks like 9 ports. Or, excuse me, under 1,000. My bad. So 1, 2, 3, about 3 ports. Looks like to me. What is this machine vulnerable to? Answer in the form of. Okay, so yeah, that with that indication, looks like it's probably going to be some type of MS17 vulnerability. So let's just do let's do an SMB. Let's see what we get. SMB version. So let's see. Use 25. options. Let's just run it real quick. And then we can also use 5 here as well, just to see if 5 will also work. Okay, so let's use 5. Okay. Let's run it. Well, at the very least, we know it is going to be some type of MS, right? So, looks like it didn't like that. It is 10.4.30. Oh. Why did it? Oh, it may have kept it from the other time. Okay, so let's do unset G. Or unset, was it unset all? There we go. R. Okay, just make sure. So, options, set our host to that. Okay, and let's run out. So it looks like it is vulnerable. M17 010. Sweet. So gain access. We start a Metasploit already. Find the exploitation code. We run against the machine. So we know it's susceptible to MS17. So let's do that. I'm gonna use, where's that? 0. So this guy right here. What is the name of this value? It's probably our host, if I had to guess. Sweet. So let's show options. I'm not sure why it keeps defaulting the R host to 10.10.4.3. Workplace. Was it not? Workspace. Work. I was like, wait a minute. Yeah, so workspace. Let's do workspace tech H again. We'll do workspace tech D 3 section. I don't know if I can do like this or not, but we'll try. Okay. 3 section 2. TryHackMe. Okay, workspace. Okay, cool. Workspace tech L section. Okay, workspace section. What? Yeah, work. Oh, it has a capital. That's why. Workspace section. Okay, and then host tech R. Okay, just make sure. Space blue. Okay, and then this is us again. All right, cool. Just get rid of all that gook, so maybe we can get it all pointed to what we want to look at. Set L port. We'll do 9988, and that looks right for that. Okay, looks good to me. Usually be fine to run this exploit as is. However, for the sake of learning, you should do one more thing before exploiting a target. Enter the following command and press enter. Okay. So, okay, as you see here, it has Windows x64 interpreter or CCP, and now we're doing shell. So, show options. What did that do? It changed for us, besides just the payload. Okay. With that done, run the exploit. Okay. Confirm that the exploit has run correctly. You may have to press enter for the DOS shell to appear. Background the shell. If this failed, you may reboot the target VM. Try running again before a reboot of the target. Okay. see if this works. Okay, fell there. That is the right handler. I may go ahead and try to ping it. Just it said it didn't respond to ICMP, but just to make sure, because I want to make sure that it does work. Okay, so it is responding, right? So does we have the right exploit running? We have the right R host of 10, 10, 233, 105. The port's fine. The L host should be fine. That's our IP. The L port should be fine as well. Which again, it is known for this exploit to go and have issues. So if it doesn't work, then it may be one of those things of where we just terminate the box, try again. So I'm gonna pause here, see if it does work. If not, we'll restart the box, try it again, and go from there. Okay, after a long effort of trial and error, I have terminated the machine 3 times. I have tried the OG payload that we were using, and I retried the new one that they chose to do. I have tried going back and forth, and we finally got a win. Actually, what happened prior to this one was it um, sometimes if you, I guess, have multiple sessions or trying to do something like that, it can spam the stager, and so it just create a lot of stages and sessions. So I had to go and terminate the machine. I kill all my sessions out because I didn't know what was going on with it, and but regardless, we're there. We finally got it in, so we can continue on. All right. Escalate privileges, learn how to upgrade shells in Metasploit. If you haven't already, background the previous shell. Okay, so we can do that. As you see, session 124. We're only at, one session here, but it spam created over 123 different sessions for us. So, okay, if you haven't already, check background, research online, convert a shell to an interpreter shell in Metasploit. What is the name of the post module we will use? To convert a shell to an interpreter shell? Huh. I don't. Shell to interpreter? But I thought we had a interpreter shell. I guess not, right? Because it's just going straight into it. It's not giving me a interpreter shell. I got it. Okay. The shell to interpreter is a module designed to upgrade command shell to a interpreter session. So I guess we're going to background this guy and search for type post. Let's see. We do interpreter. So it looks like number 13 here. So use 13 options. So sessions, set session to 124, set L host to ton 0, just in case. And then set L port to 8954. So run. It automatically detects a target platform and selects the best version interpreter for the upgrade using verse TCP payloads for Windows and Linux and Python-based payloads for other systems. It has a capable existing shell trying to gain more control over a compromised system. Interesting. So it is this right here. Wait, what? Why did it mul? What? So, oh, maybe it's talking about like the poster. That's why it is all wonky. Okay, so select this, use module path, show options. What options are we required to change? The session. We need to list all the sessions to find your target. Run. If this doesn't work, try to complete the exploit from the previous task once more. Please work. I'm begging. Okay, so it says it's stopping the exploit multi-handler. I'm going to close it. Let me see. Okay. I did get an actual interpreter shell here, so let's see. Okay. Okay, looks good so far. Let's do a shell. And oh, awesome. Sweet. So yeah, it worked. Looks like. So, all right. Great. Don't have to wait another hour for you to do it. Conversion complete. Select that session for use. Okay. Verify that we have escalated to NT authority system. Run guest system to confirm this. Okay. I mean, we are, but oh, I misspelled system. Already running. Yep. Feel free to open a DOS shell via the command line shell and run who am I. This should return that we are indeed system. Background this shell afterwards and select our interpreter session for usage again. List all the process running via the PS. So okay. Just because you're a system doesn't mean our process is. Find a process towards the bottom list that is running at NT authority system. Write down that process ID. So let's see here. So this is all the processes. What's our PID? I think it's like PPID. No. What's our PID? I thought PID would get PID. There it is. Okay, so ours is 1784. So 1784. I mean, our user is that. Like they said, it doesn't mean that our shell particularly is a authorized or NT system shell. So okay. So one that's running at the bottom. I mean, you know, we can see something like con host. It's probably one we might be able to take over. Migrate to this process. Use migrate process ID. Process these may just run down. This may take several attempts. Migrating process is not very stable. If this fails, may need run around the conversion process. Reboot the machine. Start it once again. Please work. So it wants us to go to a NT authority system also. So let's do there's a couple of CMDs here. I want one that be somewhat stable, right? So let's try 2812. And hopefully it will work. Again, migrate is not very stable. We are already into authority systems, so but dump the non-default user's password and crack it. With our elevated interpreter shell, run the command hash dump. Just dump all the passwords on the machine as long as you have the correct privilege to do so. What is the name of the non-default user? Okay, yeah, that's fine. Like again, we are already I mean, according to this, a privilege session. So I would assume that we were able to do hash dump. Oh, 1784, you know, it's right here. It's taking quite some time for this hash dump. Oh no. Copy this password hash to file. Research how to crack it. What is the correct password? Okay. Let me do get pid again. Let me just. Please, no. Okay, I think the shell broke. So, it's background session. So, show options again. Sessions. So, let's set L port to like 9900. Or let's run this again. Because I'm pretty sure the interpreter session on that one. Okay. Oh. Does it trying it again? What's happening? Show options. Yes. Yes. Session. Run. Okay. Set output to 3920. Okay. I guess it was still running it, even though I... Okay. Whatever. Let's try hush dump. Yeah. See, that's why I'm confused why I wanted us to do that, but okay. So there's John. What is the name? Yep. John. Copy the password hash to file, research how to crack it. What is the cracked password? So let's copy all of this right here. So we could probably look up, be found within the Rocky Wireless. So I wonder if it actually wants us to crack it, or if we can maybe look it up and crack it, right? If we want, we can definitely, you know, let's just do crack station. I think we've already looked it up, right? Okay, we can just search crack station. Okay, so let's clear that out. Clear that out. Okay, yeah. We can go back and try cracking this if we want. Echo. We'll dump the stuff here. Paste. So we'll do that, and then we can just make sure hashed crack. Yeah, cool. Sweet. Okay, so find some flags now. So there's 3 flags planted on the machine. They're not traditional flags, rather meant to represent key locations used below to provide to complete the room. This flag can be found at the system root. So is this saying the C drive? Yeah. Okay. So let's go. I think if I do ls, it's going to do it for. Come on. Okay. So cdc that. Cat flag1.text. Okay. So there's flag 1. This can be found at the location where passwords are stored within Windows. Windows doesn't really like the location of this flag and can occasionally delete it. It may be necessary in some cases to terminate, restart the machine. Oh my goodness. This relatively rare, however, it can happen. I wish I wrote down where I kept my password. Luckily, it's still stored here on Windows. So I take that it's at the Windows directory. I wonder if I can just do flag2.txt. I know that's kind of cheaty doodling a little bit, but I know that they normally store passwords within Windows, usually like I said in the SAM. So for an actual location, I'd be curious to see where, because I don't really know where at. Wish I wrote down where I kept my password. Luckily, still stored here on Windows. Be an excellent location. After all, administrators usually have pretty interesting things saved. I mean, I'm taking this is probably the administrator's desktop documents, downloads, things of that nature. So was it capital F? I didn't realize. No, it was not. It was lowercase. Okay. Well, I guess whenever this gets done, well, I guess actually while this is doing this thing, we can oh, never mind. I just got it back. So system32 config is where passwords are stored at? Really? I didn't know that. So cd, we'll do c windows system32 config. Oh. Oh yeah, this is SAM. That's what the SAM database is. Huh. I did not know that. That's cool. Huh. Okay. So then we can do cat flag2.text. Sweet. So we can throw that there. So let's cd back up to the C drive. Okay. Oh, I'm being stupid, sorry. Alright. Back to C drive. cd users administrator. Okay. All users default John. And I'm int system. Okay, let's maybe it's John that we're talking about here. So let's cd into John. Okay. Something in documents it looks like. So let's cd into documents. Oh, and there it is. Sweet. Flag3.text. Awesome. Sweet. So there we go. We were able to beat Blue. I do apologize for all the hiccups that was happening there. We could definitely try cracking this password real quick, just for funsies, just to make sure that, you know, it is what it is, right? So if we go back to our cartography lesson here, we can do John. And so here, there's a word list path, right? So see what word list it wants. The rock U, right? Okay, so let's do locate rock U. So this guy right here. So tag word list equals rocky.text, and then so there's the format. So I have to specify. So probably John tag format equals TLM, and then hash to crack. Wait, what? Why did it? Let's see. We'll do NTLM. Okay, we'll go back to John. So John single from drag. Okay, wireless. Let's do John tech help. So the format. Where's that at? Format. Thought that it has. Attack list format. There it is. John tag list. I keep doing that. Oops. Equals formats. Okay. So go back up. Format. Actually, we probably need to go back to. That's what they said, right? Formats tech IF. Okay. Okay. I think we can also like identify the hash, right? Thought we had a way to identify it. Oh. Hmm. Let's do net ntlm. Nano hash to crack. Okay, let's try this again. Okay. V2. Okay. TLM tech native. Yeah, that's what it said. Or not native, naive. Well, I thought we were able to crack it, but it looks like I am struggling to figure out which one to crack it with. Because I thought there was a way we could identify the hash. Like, it would did tell us. I think that was the Python thing, if I remember correctly. It was something with Python script. Because it was definitely for cryptography. Um, but it looks like I'm not seeing that. Actually, let's just go back. Why not? Let's see which one it is. I think probably John Ripper help us out. Uh, okay, so it's TecTac format in T. Oh, really? Okay. Yeah, I thought there was a way to identify it. Yeah, because that's it. Hashtag ID dot py, and it did crack it, right? But hash tag ID. Did I not take notes on that? I thought I did. Huh. Well, I'm definitely adding that into our notes. I thought I added that in. I don't know what I was doing. That section. So, all right. Okay. Cracking the big word. Keep doing that. John TecTac wordless. And yep, that's it. Okay. Well, that's how we identify it. But yeah, I could have sworn that we took those notes on the .py. Maybe I just didn't do it or forgot to. So, well, at the end of the day, we were able to complete blue. We were able to go back and just make sure to go back and ensure that our notes were good to go. We were able to crack the password there, so that's great. Um, I apologize for the Metasploit being a little wonky this one, but we were able to get there. So, all right. Here we are. So we are in the last two modules. So we have just what, 7 lessons left, and we will be done with the complete beginner course. So hope you enjoyed this episode. I had a great time going through Windows exploitation, learning a lot about Metasploit, learning some cool tools and some things with like the workspaces. That was awesome to learn about. Did not know about it. And as well as going in there and doing a little CTF, somewhat CTF for Blue. So, hope you enjoyed this episode. Please leave a like, comment, explain, what you thought your favorite thing is or something maybe you learned. And hope you enjoyed this episode. Thank you for watching and hope you have a great day.